First question is, a bullet is fired horizontally from a rifle at a distant target. Ignoring the effect of air resistance, what is the horizontal and vertical acceleration of the bullet? According to the statement, the bullet is in projectile motion. For projectile motion, the horizontal acceleration is going to be equal to 0, that is ax is equals to 0, and the vertical acceleration is going to be equal to the gravity, which is always equals to 9.8 meter per second square. So option C is going to be our right answer. Next is, a stone is dropped from the top of a cliff of height 30 meters. At the same instant, another stone is projected vertically upwards from the ground with a speed of 30 meters per second. The two stones will cross each other after a time. The solution is going to be like this. When the stone is dropped from the top of a cliff, it will be S1 is equals to half GD square. Then, when the stone is projected vertically upwards from the ground, the formula is going to be S2 is equals to VIT minus half GD square. We are going to add S1 and S2. Suppose S1 is equation 1 and S2 is equation 2. We are going to add equation 1 and 2. We will get S1 plus S2 is equals to VIT after some calculations and cancellations. Okay, so the final answer is going to be, as we have to find the time, it will be 1 second, option A. Next question is, which of the following must always be true? We have to find the true or the correct statement. So according to second law of motion, if an object's acceleration is 0, then its speed must remain constant. That is option 2 from the statement or the question given. So from the options, if we have to see, it will be option C2, only because only that is the correct statement. Next is, a stone is thrown horizontally with an initial speed of 30 meters per second from a bridge. Find the stone's total speed when it enters the water 4 seconds later, and you have to ignore the air resistance as it's clearly mentioned inside the brackets. We are going to use the formula V is equals to VIX squared plus G squared T squared and square root. Okay, these are written inside the square root. V is the velocity, G is the gravity, and T is the time. After putting the values, you're going to get the full and final answer, option C, that is 50 meters per second. Next question is, a baseball is thrown vertically into the air. The acceleration of the ball at its highest point is, you have to remember that at the highest point, the acceleration is always equal to the gravity and its direction is always downwards. So as the baseball is thrown vertically into the air, its direction is going to be downwards and its acceleration at the highest point is going to be equal to the gravity. So option D is going to be the right answer. Next question is, a feather initially at rest is released in a vacuum 12 meters above the surface of the earth. Which of the following statements is correct? You have to find the correct statement. You have to remember that a freely falling body has constant acceleration, that is, the acceleration is always equal to the gravity for a freely falling body, and as they have clearly mentioned in the question or the statement that a feather initially at rest, by this it is clear that option B would say that the acceleration of the feather remains constant during the fall is going to be the right answer. Next question is, an object dropped from the window of a tall building hits the ground in 12 seconds. If its acceleration is 9.80 meters per second square, the height of the window above the ground is. So we are going to use the formula over here, that is S is equals to half GD square. By putting all the values that are given in the statement, you're going to get the full and the final answer, that will be 706 meters, option A. Next question is, in which case does the potential energy decreases? Before finding out the right answer, I need to explain you something first. That is, in comprehension or extension of a spring, work is done against the restoring force. In moving a body against gravity, work is done against the gravitational force of attraction. First, it's done in comprehension or extension against the restoring force, then it's done when you're moving a body against gravity, it's done against the gravitational force. Okay, it means in all the three cases potential energy of the system increases, but when the bubble rises in the direction of the upthrust force, then system works, so the potential energy of the system decreases. Therefore, as we're going to see the option A on the rising of an air bubble in water, this is going to make some sense according to this explanation given. So option A is going to be the right answer. Next question is, in the diagram given below, in which case the acceleration is maximum? Case A and case B is given. We're going to find the acceleration of both of these. For case A, when we're going to find out the acceleration is going to be minus 1 meter per second square, and in case B, when we're going to find the acceleration is going to be minus 0.5 meter per second square. And as we have to find the maximum value, so option C, that is case A, is going to be the right answer. Next question is, Newton's laws do not hold good for particles which? So Newton's laws do not hold good for particles which move with velocity comparable to the velocity of light, because it only holds good for massive bodies having small velocity. So option D is going to be the right answer. Next question is, a person standing on a horizontal floor feels two forces, the downward pull of gravity and the upward supporting force from the floor. These two forces, we have to find the correct statement, and as the person is standing on a horizontal floor, feels two forces. He's feeling two forces, but that doesn't matter. The floor is only one, means the floor is just a single object, right? So because two forces are on the same object, therefore they're going to have the equal magnitudes, but they're not going to form an action or reaction pair. So option B is going to be the right answer. Next question is, a rocket works on the principle of conservation of. The basic principle along which the rocket works are only two, that is the law of conservation of linear momentum and the Newton's third law. So as for the options given, we are going to see that option C, linear momentum, is going to be the right answer. The next question is, an aeroplane is flying at a constant horizontal velocity of 600 km per hour at an elevation of 6 km towards a point directly above the target on the Earth's surface. At an appropriate time, the pilot releases the ball so that it strikes the target at the Earth. The ball will appear to be falling. Now, as the pilot will see the ball falling in a straight line because the reference frame is moving with the same horizontal velocity, but the observer at rest will see the ball falling in parabolic path. So on a parabolic path as seen by an observer on the ground near the target, that is option D, is going to be the right answer. Next question is, a ball is dropped from a height of 10 meters. It is embedded 1 meter in sand and stops in this process. Now the collision made in the statement is actually an inelastic collision, and during inelastic collision only momentum is conserved. So option A, only momentum is conserved, is going to be the right answer. Next question is, an airplane flying 490 meters above ground level at 100 meters per second releases a block. How far on ground will it strike? We have to find the distance, that is, they're asking how far on the ground will it strike. So for that, we are going to use a formula that will be U into 2h over g under the square root. So we are going to apply the values, and then we are going to get our answer, that will be 1000 meters. But as we have to find the answer in kilometers according to the options, so when we're going to convert it into kilometers, it will be 1. So option A is going to be the right answer. Next question is, when a body moves in a straight line, then its displacement coincides with. As in a straight line motion, magnitude of displacement is equal to distance, so the displacement coincides with the distance. So option A is going to be the right answer. Next question is, when two bodies stick together after collision, the collision is said to be. So when the two bodies are going to be stick together, all the kinetic energy is going to be lost. So collision is perfectly going to be inelastic. That is, all the initial kinetic energy is not going to be equal to the final kinetic energy, because the final kinetic energy is going to be 0. So option C, completely inelastic, is going to be the right answer. Next question is, a particle A is dropped from a height and another particle B is thrown in horizontal direction with speed of 5 meters per second from the same height. The correct statement is, we have to find the correct statement, and for both the cases, that is when a particle is dropped from a height and when the particle is thrown in horizontal direction, the formula which will be applied is going to be same, that is T is equals to 2h over g under the square root, and it's always equals to constant, because vertical downward component of velocity will be 0 for both the particles. So both the particles will reach at ground simultaneously, and option C, according to this, is going to be the right answer. Next question is, the collision between two bodies may be elastic if bodies are. It's a general question which has been taken from the definition itself, and it's going to be solid and hard, option C. Our last question is, at maximum height on the trajectory, which of projectile becomes 0? Now, because at maximum height Vy is equal to 0 and Vx is equal to constant, so the projectile Vy is going to be equal to 0 at maximum height. That is the vertical velocity, option C.